Okay, in this video what we're going to do is we're going to interpret area under a normal curve as probability. We're going to look at a familiar example, which is the height of American men. So the height of American men is normally distributed with mean 69 inches and standard deviation 3 inches. What proportion of American men are 72 inches or taller? Okay, so what we're going to do is we're just going to draw a normal distribution curve here. Here's 69. If I add 3 standard deviations, 69 plus, if I add 1 standard deviation, which is 3 inches, I get 72. So 72 is 1 standard deviation above 69 inches. And if you subtract 69 minus 3, you get 66. Why am I talking about that? Because the standard deviation tells us how spread out this curve is. So what you could actually do is just by using the empirical rule, you can figure this problem out, because if these are standard units, then we have 68% is in the middle. And I write this calculation before. I'm just going to sort of do this in my head now. Is that if you take 100 minus 68, you get 32, and half of that makes 16. And so that'll go in each of these tails. And so that's a little messy over there, but those all add up to 16 plus 68 plus 16 makes 100%. So we're looking at this guy here above 72. Well, 72 is 1 standard deviation, so it's that area 68%. If I use the TI-83, I'm going to write second distribution to normal CDF. And what I'm going to do is looking at the left endpoint 72. It goes on forever, so it's E99. The standard deviations, or the mean is 72 and the standard deviation is 3. I'm going through this a little fast because we've done this in other videos. And so, so it's just sort of a review here, but maybe it's not even worth it because I'm going so fast. But that turns out to be about 16%. So we could have by converting into standard units, z equals x minus mu over sigma, we could have gotten the same answer. So 72 inches is 1 standard unit. So by using the empirical rule, to be above 1 standard unit, it's 16%. But, we have the calculator too. So this is the proportion. So the proportion of men in the U.S. Who are 72 inches, which is 6 feet, or taller, is 16% approximately. This data here, by the way, is the source for this information is Haynes 5, which is a study done in 2003 around the height and weights of Americans. Okay, so that's proportion of population. 16% of the population is 6 feet or taller. There's 12 inches in every foot. Okay, Now, suppose if I ask the question, well, if I randomly select a person, what's the probability that they're 6 feet or taller? It's that 16%. So if I randomly select a man in the United States, there's 16% probability that he's 72 inches or taller, because that's the proportion of men, 16%, that are 72 inches or taller. And so we think of area as proportion of the population, but we also can think of area as probability. So area can be thought of as probability. So for this example, we're going to just follow up on that, on what we just did there with the height of American men. And so again, assume the height of American men is normally distributed with mean 69 inches and standard deviation 3 inches. The standard deviation tells us how spread out the data is. When I say the average is 69 inches, that means almost all men are 69 inches. Well, how we can interpret the standard deviation is by using the empirical rule. If I take 69 minus 3, that's 66 inches. So 5'6". 69 plus 3 is 72 inches, 6 feet tall. So within that range of one standard deviation, 66 inches, 72 inches, the empirical rule says that's 68% of the population. So 68% of the population is within one standard deviation of the mean. That's the importance, an application of the importance of the standard deviation, showing that how spread out the data is. Okay, the question is, what's the question? So, what is the probability that a randomly chosen American male is 70, well, actually, let's not do 72 inches or tall, or we already talked about that, is between 67 and 71 inches tall. So again, there's 12 inches in a foot, so 12 times 5 is 60. So this is 5'7", and then this is 5'11". So the solution is going to be written as follows: probability that X is between 67 and 71. X is the height of an American male. Okay, and what I'm going to do is I'm not going to use the empirical rule, because this 67 inches is not, say, one standard deviation from the mean. The mean was 69, you can see above here. So 69 minus 67 is 2 inches. So that's 2 out of 3 inches. 2 inches out of 3 inches. So it's 2/3 of a standard deviation. So it's 2 inches away from the mean, but one standard deviation is 3 inches. So it's 2 inches out of 3 inches. So it's 2/3 of the mean. And I have not memorized, the values for 2/3 of a standard deviation, those ranges. I'm going to use, as I showed in the other page, the TI-83. So I'm going to use normal CDF. I put the left endpoint is 67, the right is 71. So that's the left, the right, and then 69 is the mean. And then sigma, is 3. I put this in the calculator. Should I say one more time what those buttons are? Second, distribution. Number 2, normal CDF. Okay, and then I put those in there, and apparently I'm going to get 0.247575, which is around 25%. So that the probability, the chances that a randomly selected American adult male is between 67 inches and 71 inches tall is 25%, which is the same as the proportion of adult men that have that height. Okay, the thing is that in the original statement up here, I'm going to change it. I just said American males. I'm going to write 18 and older. Or to 65 years old. 18 to 65 years old. So people start shrinking when they get older too. So, okay, so the proportion of men that are of adult men between 18 and 65 that are 67 to 71 inches is 25%. That's the same as the probability that if you randomly choose someone or find someone somewhere, that that's the probability that they're going to be within that range.